Welcome everyone to Mechanical Design Hub. So let's subscribe our channel for mechanical design, Ansys, SolidWorks, CATIA, mechanical design, course related, job related and engineering related videos. So let's go to our topic. So today we will learn how to make the CFD analysis between two phase analysis. This is air and water. Okay, so let's start our drawing. So at first you have to go to the fluid flow fluent. Just double click on fluid flow fluent. There, then it's the geometry, then right click on it or double click on it. Then this is open. Just go to the new design modular geometry. Okay, wait, it needs some time to open. You can see that the design modular has opened. Now you have to just change the unit system to millimeter. Okay, then go for the file and just import external geometry file. Then go for this drawing, just I have created in the SolidWorks previously. Then go for the generate option. So it takes some time to generate this drawing, so don't skip this video, please watch till end and just comment the queries you have, and I am just making this tutorial for you. Just you have seen that this design, there are the two inlet pipes and that is mixed with one horizontal pipe, and this horizontal pipe is mixed with the air. There are the water coming here and there will be the air instead of water. Okay, this will be the solution. We will just animate the velocity the velocity contour, pressure contour and the temperature contour, and we will assume that the two velocity of the two water streams will be 0.6 meter per second and this temperature will be 300 Kelvin. Okay, so just I have generated to the design modular. When you have just generated that, nothing to do, just click here exit. Okay, just you after this geometry have the green tick, then go for the meshing, double click on meshing. Just you have seen that this model has come to the Ansys meshing, fluent meshing, and here you have to just making the mesh here. So at first you have to change the unit system, that is already in the metric millimeter. Then go for the mesh, just there is the element size. I am just changing this element size to 10 millimeter. Okay, then this element order will be linear and the solver preference will be fluid and the physics preference will be CFD. That's nothing to change here. Then go for the sizing. There the sizing have to change that the curvature, capital curvature will be no, because in the curvature sections we don't know the extra mesh will be happened. Then go for the mesh and insert and go for the method. Okay, just when the method come, then select the whole body and go for the apply, and here you have to change the method. This method will be tetrahedron. Okay, and the algorithm is the patch confirming, element order is everything is okay. Then go for the mesh and click here generate mesh, and it takes some time to generate the mesh. Okay, here everything is okay. This is the element order is linear 10 millimeter, and one thing is I have to change see that the capture curvature is no. Okay, you can see that the mesh has been here. Then you have to once again update the mesh. It takes some time. Okay, this has been updated. Then just click here. You can see that the mesh has been tick. Then go for the setup, double click on setup, then go for the double precision. Okay, and go for the parallel. In the parallel you have to just increase it to 4. Okay, and then go for the OK. One more thing, I have just yeah, please wait, that is just one more thing I have just forget that. Please click here mesh, that I have to change one thing in the mesh. Please wait, the mesh window has been open. It takes some time, you can just skip. How much time is needed? You can see that the mesh window has opened. Okay, you can see the mesh window has opened, and if you go for the mesh, that you can see that mesh has already done. Okay, here we have to give some name. So go for the face icon and just select this part and just go for the create name section. There will be the inlet 1. I just give this name. Okay, inlet 1, and again I am just select this portion and go for the create name section. This will be inlet 2, and this portion I'm just giving the name outlet 1. Okay, in the previous time I have just forget to give the name, so if this is okay, then go for this and make it update, and you can see that the update has been done. So no, nothing to worry, that click here. Okay, then go for the setup. And then this option has been open. Please wait, then go for the double precision and just double precision in this parallel window, then just make it 4. The process will be 4. This will be the double precision, and just click here. Please wait, and then click here OK, and you can see that the Fluent window has been open. Please wait some time until it's opened. You can see that the Fluent window has been open. Now you have to select some of the options here. At first you have to select the time will be transient. Okay, the gravity, this gravity will be minus 9.81 meter per second, and the velocity will be absolute. Please wait, I'm just checking here. This will be check only transient, and just this velocity will be absolute. You can see that there is the absolute, there is the pressure base, there is the transient, and the gravity. I give the gravity value and all is done. Then just end it and go for the setup, then go for the models. Okay, in the models first is the multiphase, and in the multiphase window have been on, then go for the volume of fluid. Then there is the two phase, one phase is the water phase and that is the another is the air phase. So the number of the phase will be 2. Okay, and everything is okay, then go for the OK button. Volume, and then go for the OK button. Just click here on the OK button. Then you have to just go to the material portion, then double click on material. There is the come. Okay, there just create on create, there go for the Fluent database, and just in the end up portion you can see that the water liquid. Okay, that is the water liquid. Just once again click copy, then close, and then close. You can see that the water liquid has been added to the library section, and all is have been done here. So when it is going to be done, then go for the multiphase, then go for the phase, and that is the first phase. Double click on first phase, and in the first phase you can see the first phase will be air, and phase material is there. Click here OK. Just edit this, edit. The second phase will be water, the material will be water liquid. Then click here OK. Then go for the phase introductions, double click on it. Go for the surface tension, click here surface tension, force module, and there you have to give the surface tension coefficient of the water. This coefficient will be 0.072. Okay, just I am giving this surface tension coefficient here and click here OK. Okay, now you have to, after changing these two phases and this the surface tension, then you have to just go for the boundary condition. Double click on boundary condition, go for the operating condition, and click here the separate operating density. When it is shown, just click here OK. Okay, then again go for the boundary condition, double click on it, and you can see this the 5 parts here. Just go for the inlet, and when it will be the mixture, then go for the edit. In the inlet portion, there will be the velocity magnitude will be 0.6 meter per second. Okay, and there if you go for thermal, I am just making this give its velocity, then it's is the velocity. Okay, and I'm just giving the velocity of 0.6 millimeter inlet. Okay, just click here OK. Then again when it is selected, go for the inlet will be water, and just click here edit. When it is come, there will be the volume fraction, then give the volume fraction will be 1 and click here OK. And you can see the inlet 1 is having done. Then go for the inlet 2, then when it will be the mixture, just go for the edit and give its velocity will be also 0.6 and click here OK, and then change it to water, and when it is selected, then go for the again edit. and just give its fraction 1. Click here OK, and now comes to the outlet. When it is mixture, just give edit, and you can see that this is the pressure profile, multiple layer 1, gauge pressure is 0 and everything. Then click here OK, and you need not to change anything. Then you have just done with everything in the boundary condition. After you have done with this boundary condition, then go for the solution, go for the method, double click on method. Then this it is come to piezo method, and everything has been done. Just select the piezo method, then go for the initiation, go for the hybrid initiation. Just click here initialize, and just the patch when shown, that click here. Then you have to just go for the calculation activities. Then you have to go for the calculation activities, select here 1 and click here create solution data export, and you have changed the format to CDAT for CFD in light, and everything is on OK. Just binary, just select everything and click here OK, and when it will be binary, you can then select everything from the left side and click here OK. Then you have to go to the run calculation page. In the run calculation page, you have to give some of the values, and this will be the first will be the time step size, and this is the number of the steps. I am just making it small, so I am just giving it 100 number of the time steps. The time step I am just giving 0.001. okay, number of the time steps will be 100, and the maximum iteration per time step, maximum iteration I am just giving it 10. okay, and just you have to, after that you have to click here the check case. okay, when it comes to the check case, then go for the calculate option. Just click here calculate. It takes some time for the calculation, so I'm skip this video, and just you can see that the calculation has been initiated and it has been done here. It takes some time, so you have to just wait and see the calculations. So you can see that the calculation has been complete. This became the curve, and this is the continuity. This is the x velocity curve, this is the y velocity curve, this is the z velocity curve. When the calculation has been complete, then go for the OK. You can see that everything is complete. Just click here to I'm just minimizing here. okay, then you have just come here to the result in the workbench window, go for the result and double click on result. Then the CFD post processor has been opened, so it takes some time to open the post processor. So don't skip the video, comment below what type of tutorials you know. Just subscribe my channel for latest technology videos and tutorial updates, so don't forget to subscribe my channel. Okay, then at first you have to go to the insert option, then go for the contour option. I am just give it the pressure 1. Okay, this is the pressure 1. I'm just seeing first contour in the wall part, and this variable I'm just giving here the variable pressure. Okay, you can give the mask flux. I'm just showing the mask flux also. The range will be global and just the contours will be 50, and click here apply, and you can see that this is the pressure contour, okay, in the wall section. And you can go again in the insert contour section, just give it pressure 2. okay, just if you make what is it is going to save there, you can see that will be saved here. Okay, so here I am just giving it to inlet portion, inlet, and give it pressure, and the contour will be 50. Okay, apply. Just you can see that I am just giving the pressure contour in the inlet portion, and I'm just giving it to contour pressure 3 to the outlet portion, just giving it 50, and in the outlet portion there will be the pressure contour or temperature pressure contour in the outlet portion. Is this how you can make the CFD analysis of the two pipes? Both are horizontal and that is mixed with the vertical pipe, and this will be the pressure contour. Okay, and there are the 3 pressures. If I am just making it mass flow rate, density, air volume fraction, air density, heat flux, and how it is happening, let's see. And this will be the heat flux. There will be the no heat flux because I am just not changing any temperature, so I am just giving the velocity, so it is going to calculate the value of pressure contour only. Okay, and this is going to be our video. Let's subscribe our channel. Don't forget to subscribe, share, comment, join our Telegram group in the description below, and